Hello and welcome to my session, Immersive Future. Simply put, I will be talking to you about the intersection of artificial intelligence, AI, generative design, and XR. My name is Melanie Dawson. I'm the founder and managing director of two companies, Origin 7, a BIM and digital construction consulting business, and our spin-out company, Origin 7 Digital, which specialises in training for the built environment on all things BIM and digital through delivering live training sessions and interactive online content. Our mission is very clear. We are here to simply explain what building information modelling and digital construction is really all about. We do this using plain language, targeting the areas where these processes or technologies will make your job easier and support your profit margins. So let's get into it then, starting with a brief overview of AI, generative design and XR. Artificial intelligence, or AI, refers to the simulation of human intelligence in machines. These systems are designed to perform tasks that typically require our human intelligence, our problem-solving skills. Things such as reasoning, problem-solving, perception and language, lots of different types of digital understanding. AI can be categorized into narrow AI, which is typically the type of thing that we would see through like voice tasks or voice assistants. So if you've used Siri today, you've already been tapping into AI. And then we also have the more wider general AI, which aims to perform really any of the intellectual tasks that a human can do on a daily basis. Looking then at generative design, so simply put, generative design is a design exploration process. That's the best way to describe it. And it uses algorithms and artificial intelligence to generate a wide range of design solutions based on specified constraints and parameters that we set in place. Designers input their goals and their constraints, and the software iterates over and over through numerous possibilities, often producing innovative and optimized designs that designers may not even have thought about themselves. It's becoming a much more widely used tool on the projects I'm working on, particularly in the field of architecture and engineering, but also in product design, particularly with component parts and materials going into construction projects. The third one on there is XR. So XR is essentially an umbrella term, and it encompasses all of the other immersive technologies that most of you will have used on your projects by now. So the likes of virtual reality, augmented reality, mixed reality, and those technologies blend both the physical and the digital worlds together to some extent or other, depending on which one you're using. VR is the fully immersive experience, so you're completely in that digital environment with your headset on. Augmented reality, or AR, overlays the digital content onto the real world, and then the mixed reality, or MR, combines elements of both of those, but also allowing you to do the interaction piece there as well. When we look at artificial intelligence then, so what does that mean? So first of all, let's set the scene a little bit here. So just imagine if you could accurately compare 3D models with 2D drawings at the touch of a button. What if you could find the best subcontractors to match your job requirements, again, at the touch of a button? Imagine if you could analyse project opportunities so you can find the most profitable work that suits the skill sets of your organisation. What if you could generate procurement logs to check for missed items or perform risk analysis? All typical things a few years ago were very manual tasks. Now many are using AI to perform them. What this is doing in turn then is freeing up the time of a lot of people, educated, smart, intelligent people in the industry, freeing up their time for other tasks whilst letting the computer crunch the data in the background. The key to all of this, of course, good quality structured information, good quality data. And again, that's where BIM and having that structured approach to information really starts to come in. Generative design then is next, and that's the process really that is tapping into a lot of these algorithms, a lot of this information, a lot of these data sets that we have built up. And really AI is there to explore a vast range of design possibilities, again, based on specific goals, constraints, parameters that we set. So you might be using generative design tools already on your project, so the likes of Dynamo, Fusion, Grasshopper, Rhino, Dreamcatcher. There's lots of different solutions out there. But simply put, you can decide how you want to structure your building, structure your new product, for example, and you feed in the information, and these tools will produce different outputs. The one that you can see on the screen here was one that I ran quite quickly. Again, what I was asking it for was to produce like a garden ornament for me. I told it I wanted it to be silver in colour, metallic finish. I wanted it to be organic. I wanted it to incorporate circles and organic shapes, and I wanted to be able to 3D print it at the end. So those were the parameters that I input, and these are some of the potential solutions then that were produced on the back of that. So the steps I followed, I input the parameters, and again, that's what you would be doing as designers or construction people. You input your goals, your constraints, your parameters, and that may be around the materials, it may be around budget, site conditions, performance criteria, for example. You then start the generation process, and that's where the software kicks in to really help you with this. It will generate multiple different alternatives for you. You then analyze these and decide which one best suits your needs, which one best suits the parameters that you've set, for example. And then you can narrow this down and it helps to make that selection process. So it really is a bit of a superhero in the design process, and it should really help us to speed up this process going forward and get some really innovative design solutions as well. Looking just a little bit more at generative design, so lots of tools out there to do that. And again, what we're doing is inputting those parameters to do it. The likes of Fusion is another one that I'm seeing being used increasingly, particularly in the product manufacturer section. Where people are designing either, say, for example, modular buildings, or perhaps it's panelized systems. But again, the same principles apply, where we're inputting the parameters, we're generating the designs, we're coming up with the solutions, we're able to analyze these at pace, we're able to optimize those solutions and then select the right one for the job. So again, different tools, just depending on where you are in the industry to support. The third one on there then is the extended reality, or XR. So as I've explained, it's an umbrella term really, and it includes all of the different types of reality that you can see on the left-hand side of the screen. So the virtual reality, that fully immersive experience, the augmented one where we're overlaying digital content onto the real world, and then also the mixed reality where we're combining both of these things together, but also creating that interaction between both the physical and the digital objects. So examples of mixed reality include the likes of Microsoft, their HoloLens, which some of you may have used already. And again, there's lots of different industry applications for the likes of the HoloLens. I've used it on projects. We had the hospital project, and we used mixed reality to engage doctors and clinical staff, for example, in new operating rooms, but they were able to explore the spaces and provide that real-time feedback, for example. But extended reality is essentially that umbrella term that includes any of the reality solutions that you can see on the screen there. What we're seeing more and more is the convergence of the three things that I've talked about. So artificial intelligence, generative design, and XR as well. The AI part of it significantly enhances really the generative design process, and they're very complementary. It's helping to optimize and support efficiency really, and that's through the AI algorithms that are generated through the AI process. So we're able to quickly generate and evaluate thousands of design alternatives based on those constraints and those goals that we have set at the start of the project. This significantly speeds up the design process and ensures that the optimal, the most efficient design solutions are identified and as early as possible. So we're starting the projects off on the right foot. The second one is just the predictive analysis. So what I'm seeing increasingly in industry is that AI can be used to predict the performance of different design options by analysing all of the data that we're inputting about them. But we're also starting to see more and more that it doesn't just predict the performance of the design, but it also can help to predict what may potentially be coming next. So again, it's understanding better and better the information that we're feeding into it and starting to make future predictions, as well as helping us design for today. Innovation and creativity is another big one. So AI is promoting that really divergent thinking, and it's exploring unconventional design possibilities. So again, opening up the mindsets of designers to things perhaps that they hadn't considered before, more organic forms, more organic shapes, for example, and all because the software is able to generate those at pace, but also meet with the parameters that we're able to define at the start. So it's opening up innovation, creativity, and options that perhaps previously we hadn't considered. It's also supporting with data-driven decision-making, and again, linking back to BIM and the structured information. This is really one of the big long-term outcomes. What AI is doing is helping us to leverage the likes of machine learning as well now. So to not only analyse the historical data that we have and the trends from that, but also helping to provide the insights that we need for better design decisions now, but also to allow us to create better designs then for the future as well. That data-driven approach enhances the accuracy and the relevance really of the designs that we're producing now and the buildings that we're producing for the future. Customization is also key in that personalization piece. And again, I think it's important to highlight that AI can tailor designs very much to meet specific user needs. So this idea that we're going to have lots of clones and lots of things the same, I haven't yet to see an AI engine that produces two designs that are exactly the same when we have different user needs and we've set up different parameters for these. So they really are helping to create solutions that match our customers' needs, and also in the short term and in the long term. Collaboration and integration are also key factors to consider. So what AI is helping us to do is to facilitate that collaboration and those open conversations between different stakeholders. And it's doing that by providing really a common platform for sharing and refining design ideas. So we can generate these things very quickly. We can share those with others. We can get real-time feedback, and then we can continue to iterate and make that better and optimize the solutions. But really what we're doing by incorporating AI into generative design is allowing designers to achieve more innovative, more efficient, and more effective outcomes. Ultimately, this will be helping to transform the way we approach design challenges and it'll be helping us to get to the right solutions much quicker. Extended reality, XR, for short, plays a crucial role in all of that. So particularly in the visualization space and the interaction with the generative designs, for example, that we may have produced on a project. Here are some of just the key ways that XR really helps to link into and enhance the generative design process, starting with the immersive visualizations through the likes of virtual reality, for example. We're allowing designers and stakeholders to experience that generative design in a fully immersive digital environment, so helping them to understand spatial relationships, what spaces feel like, what the aesthetics of a building really feel like at a human scale as well. Similarly, with augmented reality, we're allowing them to put those overlays on top of what they can see in the real world and helping to engage with users and get that feedback. We're also looking at the interactive exploration really of mixed reality. So again, seeking that feedback as we go, combining the elements of virtual reality and augmented reality in the one space, allowing those users to interact both physically and digitally with the objects that they can see. And this essentially acts as the real-time feedback that we need and helps to iterate and optimize those design solutions before ideally we get to site. Real-time collaboration is also a really important one, and the XR technology is enabling very much that real-time collaboration amongst team members. So regardless of their physical location, we're able to collaborate on these 3D models, these generative designs, this information from remote locations, and get faster decision-making really in the process as well. So some examples then of generative design that I have seen. So one of my favourites here is the Haidar Aliyev Centre. So this one designed by the late Zaha Hadid, one of the most notable architects known really for utilising modern design methods and a really iconic building here. But this Haidar Aliyev Centre is one of the most renowned creations that she produced. Curvy building, landmark in Baku, the capital of Azerbaijan. And you probably say it resembles more like a spaceship really than a building, but an absolutely stunning example of generative design in action. Lots of modern tools have been used to make this one possible, to help create that shape, to help set those design parameters, and how it allows the building to adapt to the different topography on that particular site as well. All these carefully planned using algorithms that provided the perfect interior as well. So it's beautiful inside and out, but a fantastic example of organic generative design. On the other side of that, then we have other examples of generative design, which are much more logical, much more practical, and have a much bigger focus on the end user and what the space will feel like. On the screen, you can see an office building, this time using generative design, AI and XR to create the best possible working spaces. So much less organic in form than the Zaha Hadid building. But again, key parameters were performance focused instead. The final building then from the outside is the Autodesk Technology Centre in Toronto. And on this project, the architects used a piece of software called Dreamcatcher. So they were able to input their design goals, their constraints, their parameters into that in terms of the number of employees, how they would like to see the layouts. They highlighted the importance of natural light and ventilation, for example, and they were able to produce a stunning building which performs very well for all of the staff and visitors. The result, modern and flexible office space that fosters collaboration and innovation amongst employees. So that's the perfect outcome. Again, using generative design, using artificial intelligence, and using various immersive solutions along the way. Those are just a few examples of past projects, but what does the future hold for all of this technology? So if we looked at artificial intelligence, so just a few predictions from me on this. So first of all, I'm seeing a significant increase in automation. So people are buying into this now. It's no longer just a buzzword and they're really starting to get on board with AI. But it is so fundamental that we underpin this with good quality information, or we will end up in a state of artificial unintelligence, and I can't stress that enough. But where we have good data, the possibilities for artificial intelligence are huge. I think we'll continue to automate more construction tasks, from project planning and scheduling to on-site monitoring and quality control. And that in turn will lead to significant efficiencies and gains in terms of cost reductions and improvements in quality. We will continue to look at predictive analytics. So again, AI will enhance the predictive analytics that we're looking at the moment and the capabilities of those. But this in turn helps with risk management and proactive problem solving, which is definitely where we want to be looking at. That in turn then helps with anticipating the likes of project delays, any cost overruns, any health and safety issues. And again, all key issues, if we can address those with information, would be fantastic. With artificial intelligence, we're also seeing a lot more integrations with robotics as well. So the use of AI-driven robots for tasks such as the likes of bricklaying, welding, demolition. Again, becoming more and more commonplace and a good solution to the labour shortages that we face in industry. From the sustainability side as well, then AI will play a crucial role in promoting sustainable construction practices, doing that by optimising resources and generally reducing waste from start to finish. On the generative design piece, we're seeing again a lot more adoption of this, but generative design will evolve to provide a more holistic solutions, I think. So integrating the architectural, structural, mechanical all into the one single cohesive model. At the moment, we still see them being used slightly in isolation. We're predicting that there'll be more real-time optimization as well, so that ability to generate design in real time and do more and more of the interactive piece, and also just enhance collaboration through generative design as well. So an increasing number of tools are coming onto the market that will facilitate better collaboration amongst the different designers and provide a common platform for exploring and refining the design options that we come up with. The final one on generative design is just the data-driven insights. So leveraging a lot of the historic data that we have through machine learning to help inform the generative design of the future. So using our lessons learned to actually inform the design of the next project. The last one is just the extended reality piece then. So Again, we're seeing this continuing to grow and more sophisticated as more sophisticated tools come on the market. But the use of VR and AR for the virtual prototyping piece, we're seeing an increasing demand for that. So less demand for on-site mock-ups, for example, and much more demand for virtual versions of those. On-site assistance, so we're seeing AR and MR used more frequently for on-site assistance by overlaying that digital information onto the physical environment. Again, this is helping the different people out on site follow complex instructions and helping to reduce the errors then as well. XR will also transform, I think, the client engagement piece as well by offering a lot more of the immersive walkthroughs and the interactive design reviews, making it easier essentially to convey the design intent going forward. But with all three, with AI, generative design and XR, we're seeing that they're becoming increasingly complementary. They're becoming increasingly convergent in what they're doing, and they continue to grow at an exponential rate at the moment in terms of adoption and new tools coming out, which is an exciting space to be in. So hold on to your seats. We're in for an exciting ride ahead. That's all from me. So I've been Melanie Dawson. My contact details are on the screen. Thank you so much for listening, and I hope you have a great day.